The 16th question says that let f be a function defined on this closed interval a comma b such that f prime x is greater than 0 for all x belongs to this interval a comma b. Okay, derivative is greater than 0 means the function is increasing, strictly increasing. Then prove that the f is an increasing function on a comma b. Oh, the function is increasing. We are supposed to prove that it is increasing. Okay, so the person does not want you to use the first derivative. The person wants you to use the actual definition of increasing, right? And can we use that? Yes. F be a function defined on a comma b such that f prime x is greater than 0 for all x belongs to a comma b. This is what we have, right? Okay, and prove that f is an increasing function on a comma b. And what's the definition of increasing function? That says if x1 is greater than x2 for some x1 comma x2 belong to this interval a comma b, this implies that f of x1 should be greater than f of x2. And not only this implies this, the converse is also true for this particular definition, right? This is the definition of increasing function, right? And how do we deal with this one? We can deal with this one with the help of a simple idea. And what is that simple idea? Can we use something called Rolle's theorem over here? Yes, maybe. We can use Rolle's or LMVD. LMVD is the better choice, right? LMVD can be used over here because derivative is not 0. So what we can do is take x1 comma x2 belongs to a comma b, okay? And for this x1 and x2 belongs to this interval, we can say that f of, let's say, x2 is greater than x1 as well, okay? So f of x2 minus f of x1 upon x2 minus x1 will be equal to f prime c for some c in this interval x1 x2, right? For some c, c belongs to this interval x1 comma x2, okay? And this here is derivative is greater than 0. This implies that f of x2 minus f of x1 is greater than, this x2 minus x1 is a positive quantity, yes, this is greater than 0. This tells me that f of x2 is greater than f of x1, okay? Using the LMVD, this is what we have done. This is a simple approach of proving this one, and therefore that's a complete proof of this one, right? To then prove that f is an increasing function. This we are not using the derivative, we are doing it directly with the basics of LMVD, right? LMVD is something that we have covered in the previous chapter, right? So that's all that you have in this question over here. By the way, you can also deal with the converse of this particular expression in a similar manner, that let us take x1 x2 belongs to a comma b such that f of x1 is greater than f of x1 is less than f of x2 maybe, and after that you'll have this is positive, so this will go over there, and this will become x2 minus x1 will be positive after that, therefore x2 will be greater than x1. The converse can also be proved very easily, but I think this will suffice for now. That's the complete solution for this one.